Okay, so let's do an example here with cats. So let's say that we have a cat standing on a cart, and the cat wishes to jump to another cart. Okay, so we're going to call this cart mass 1, call the other cart mass 2, and say that the cat has mass MC. Okay, and so we're going to say that cart 1 has a mass of 1.75 kilograms. We're going to say that mass 2, the second cart, is 2.5 kilograms. And let's say that the cat is a hefty 3.50 kilograms. Okay, so the cat jumps from one cart. So what happens is we're going to start with the cart on the left here. So the cat is on this cart and jumps. And let's say that what's going to happen is we know that as the cat is sitting here jumping, then the cat's moving at some velocity, this direction, velocity cat. The cart, because the initial momentum is 0, the final momentum has to be 0, which means the cart has to be moving backward with some velocity v1. Now, I'm going to tell you the difference between, so v sub s, the separation velocity. So this is the velocity relative to the cart. So when the cat jumps, the cat's pushing back on the cart to push forwards, and so that means the velocity of the cat relative to the cart is going to be 2.14 meters per second. So this is relative to the cart. So V1 is the velocity relative to the ground. Vc is the velocity relative to the ground. I gave you the velocity of the cat relative to the cart. So I want to know what is the velocity of the cart and what is the velocity of the cat. Okay. Well, initial momentum equals final momentum. So initial momentum is 0. Final momentum is m1 v1 plus mc vc. So mass of the cart times velocity of the cart plus mass of the cat times velocity of the cat. Now, what we do know is the separation between the two. So we know the difference between the cat velocity and the cart velocity. The difference between the two is this separation velocity. Okay, that's the relative velocity. So we look at that, we say, well, we can just do a little bit of algebra here. We can say that V1 equals VC minus VS, and then take that and plug it in right up there. Okay, so that would say that 0 is equal to M1 VC minus VS plus MCVC. Okay, so that means M1 VC plus MCVC minus M1 VS. So we just do a little bit of algebra there, and we see that VC is going to be M1 VS divided by M1 plus MC. So we plug in the numbers. So the mass of the cart, 1.75 kilograms, times the separation velocity, 2.14 meters per second, divided by 1.75 kilograms plus mass of the cat, 3.5 kilograms. So VC is going to be equal to 0.713 meters per second. So what about the velocity of the cart? V1, we already said, is going to be VC minus the separation, so 0.713 meters per second minus 2.14 meters per second, and so that comes out to be a negative 1.43 meters per second. That's what we expected. We expected that when the cat jumped off of the cart up here, so the cat is jumping off of the cart, then the cart is moving in that direction, the cat is moving in this direction. So what we solved for was the velocity of the cat relative to the ground. Now what happens is the cat is next going to land on this other cart that was sitting stationary. And so after the cat lands on the cat and the cart are now moving that way with some final velocity. So I want to know, what is that final velocity? So now we have to look at this part of the problem. So for that part of the problem, we have the cat here moving with some velocity here, mass the cat, and the cat lands on the cart, which has m2. We're going to say that v2 naught is 0, so it's initially sitting still. So initial momentum equals final momentum. Initial momentum is mass cat, velocity of the cat. The final momentum is mass of the cat plus mass of the cart times that final velocity right there. Okay, so that means the final velocity is going to be mass of the cat, velocity of the cat, divided by mass of the cat plus the mass of the cart. And so that comes out to be that the final velocity is mass of the cat, 3.5 kilograms, times the velocity that we had for the cat, 0.713 meters per second, and then you divide by 3.5 kilograms plus 2.5 kilograms. So the final velocity of the cart is going to be 0.416 meters per second. Okay, and so we had cat standing on a cart, had another cart sitting there stationary, cat jumps, and so afterwards we have the first cart moving that direction, and then we have the second cart with a cat standing on it moving in that direction. And so clearly up here kinetic energy was 0, kinetic energy is not 0. What happened? Where did the kinetic energy come from? The cat. Okay. Biochemical reactions. The cat burned calories in order to produce the energy necessary for this process to occur.